Today I'm talking about kind of different point of view which we can have on traditional patterns. In that kind of conference, sometimes when someone comes have his lecture on one point of view, then another come with another point of view, but there is no dialogue. So now I would like to try to compare and to the different point of view. So yesterday you have a lecture about a pattern at the church by Mirek Makovici, and another by Ahmet about a kind of construction. So I try to comment, to talk in a different point of view about the same pattern. Okay, so first you have seen this pattern from a church in Istanbul. So it looks traditional. Okay, so yeah, of course, for everybody is the same. We have to consider only. You have to reduce the pattern with the symmetries, and there is this rectangle. I enlarge the rectangle, so we have to talk about that. The point of view you had yesterday is more or less what we call the point of view from polygon tiling theory. So you see, we try to draw the polygon and to design inside some shapes. Okay, but I want to start from another point of view, because I like to work directly with the tiles. So first I search where are the stars, big stars. They are here in white. So I can I can erase inside. So we simplify a little bit the pattern. Now something in the angle. I know that here I have a 10-pointed star. Okay. Now, a 10-pointed star like that, more or less, you will see. Then, but first thing, that star, for some reason, we prefer to have the petals the same color as the pentagon. And in fact, that's what they do. Here, if I come back to the real thing, you see the petals are in white. So at some point, they decide to make an inversion. That's the same thing, the thing I was talking about on Saturday. An inversion here, because you used to have white, color, black, white, black, white, black, and these have to be white, but not it's black. It's a kind of inversion. So I do the same. And okay. Then I can put a variation inside the star. Okay, I got the pattern, but it's not exactly the pattern now because of that. The problem is here, because I did the pattern. In fact, what? Okay, from this to that, I was working tile by tile, because all the tile I know perfectly the tiles, so I can put them in the right place. So if I put the the normal tiles, there is a problem here. Why? Because you see, these vertices are not on the symmetry axis, and this is bad. This cannot be, because if you symmetrize here, you will have something very bad. This is not good. So, if you look at the pattern, at the real pattern, they have solved the problem, but it's not in a natural way, because they have to manage the tiles. There are special tiles here in order to have a symmetry axis. So that's why, in my point of view, this pattern is not a real good pattern, because I guess they had the furniture, the frame, and this was a constraint. They have to pattern inside that frame, and that's not the right way to do. The right way to do is to think about a pattern that fits more or less the size we want, and then we fix the structure according to the pattern. That's the way it works traditionally in Morocco for everything. For architecture, if the room is not good, we move the walls. That's the traditional way to do. Okay, now how is there another way to solve this without having to manage special tiles? For example, I try something, but of course I have changed a little bit the pattern. So if I change, I can have that structure. I can fill with variations, and just here's something that is not good. So I just make some change. So here, and these are regular tiles, and just this one is a special one, but the vertex are perfectly according to the symmetry line. But this is not perfect. It's a kind of arrangement with the structure. But in another way, I was thinking about a standard pattern that can fit this surface, and I was starting from the same thing but as the pattern, as the world pattern, and then I tried to do something else. You know, I'm working directly with tiles, and by tiles that give hands together. Okay. So I have to. The problem is that my symmetry axis is here. So I change the structure according to the pattern. Then what can I do? Well, I can do something like that. There is just a problem here. I fix the problem by changing the tile here. So this is, and I add, of course, variations like that. And this pattern works. It's okay. Of course, here I must have a 10-folded star. Well, it can come like that. And there is the pattern. So this pattern is very standard. All the tiles are correct, but I had to manage to change the structure. Okay. Now, but Ahmed, you were talking about a pattern, a 12-fold pattern at the workshop. It was very interesting workshop. It was amazing to see everybody with compass, roller, doing things more precisely. So, I think that I wonder where is the geometry here. I think in this workshop you are learning to use the tools. But in my opinion, this is not geometry. Geometry is to think about relationships between the line, angles, and everything. So you had a pattern. Maybe I can write it. I can design because you can do geometry with. You don't need to have an exact figure to try to understand a pattern. So the pattern was something like maybe yes. Okay, it's a hexagon. It's easy to design an hexagon with a compass, and we have a square like that. Okay, my design is not perfect, but never mind. So, what can and extended like that. So here you will have the same thing again, another hexagon. Another hexagon here, and etc. Another one here. No, something like that. It's a bad drawing, but never mind. I know exactly what I am doing. I know this has to be an hexagon. This has to be a square. This has to be triangular. Another way to do the same. Well, look at that. We have what I need is to draw dodecagon with 12. So the only thing I need is to be able to divide a circle into 12 parts. So when you divide in 6 parts, you are doing circle like that, circle like that. No? So you have this point here, this point here. So, merde. Very bad, I'm sorry. So you can divide this angle into 2. So you can do the same everywhere. So you can have your dodecagon just with a compass. Okay, it's easy. So when you have your dodecagon, then you can use symmetry. Okay. I can design this easily with compass. Now I will use symmetry. I will symmetrize along this axis. So what come now? It's the same. Yes. No, it's a very bad design. Never mind. It's again a dodecagon, and then I can symmetrize along this line, and what I get is maybe it's not exactly this one. Okay, and what I get, my figure is not very good, and I get another one here. This has to be like that, like that, like that. Okay, have another 12 here, I do the same here, and I will have another 12 here, and etc. And you see, I got my triangle, my square, triangle, and hexagon. So just what you need to understand the pattern, to understand the symmetry, and you need to be able to draw dodecagon, and then to use symmetry. Okay, so that's a point of view, but another point of view. Okay. I draw it again. I try to do a better design. Not much better, but the other point of view is to analyze the symmetries. It's again, and again. Sorry, it's very bad. Never mind. So, what's about the symmetries? So you have an axis of symmetry here, maybe another one here. Okay. Then what? Here, of course, we have symmetry axes here and here. And here, of course, so it's the same. So maybe which one I can choose? I will choose that one. Very bad drawing. Okay. It's a bad drawing, but I want to say that when you try to understand, you don't need to have a perfect figure. But so now you see that I can use a symmetry, and maybe I can remove that part. Symmetry, I can remove that part. An axis symmetry here, I can remove. So I can do everything with that part. We have symmetry axis. So if I have this triangle, I can add another one, and then I can repeat again, like a square grid. Oh, but I have to design that. Well, okay, I have to design that, but I don't need to. If I want to understand that, I can. You see, I can reduce this. I can reduce it to, for example, to this one. I don't need that because here you have an axis of. So you have symmetry axis, and I can reduce this pattern to that. And then I use the symmetry. This is like the seed of the pattern. Huh? And what is a seed? If I enlarge it like that, you know this is right angle, this is 35 degrees, this is 60 degrees. Huh? So what do I have inside? I have a square here. Yeah? It's a quarter of the square you have in your pattern. So what I need to only to trace the diagonal here, enfin the bisectrice to have equal angle here, So if I have equal angle here, I do that, square 45 degrees here, and that is my square. That's the square. So this pattern now it's only two lines. I have to draw a triangle with an angle of 60 degrees, an angle of 90 degrees. So this one comes as an angle of 30, and it's okay. That's all. And you symmetrize. And the symmetrization, it's something you can do with compass and ruler. So the point is that this drawing is just fast hand drawing, but it's not the final drawing. It's just to understand the key of the pattern. So I show you here only two ways to design these patterns. First way, you design a dodecagon and you symmetrize the dodecagon. So you just need one shape, only one shape. And second, you use every symmetry, all the symmetry. You reduce the pattern to the seed, and the seed is only two lines into a triangle, which you can design easily this triangle because the angle is the angle of 60 degrees. Okay. Now, I guess everybody knows this pattern perfectly. This pattern is a very standard one, very famous. You can see at the Alhambra of Granada, of course, and you can see it everywhere. So, first thing is to understand that there is grid behind this pattern. But it's not a square grid, it's a triangular grid. Huh? So, yes. So you need that kind of grid. And at the workshop, you will have paper with a triangular grid also. Yeah, this is like, it's something like what you can see and experiment with the book of, the last book of Myrek. Your book with, have a book with that kind of pattern on the triangular grid. And so you can experiment, you can make pattern in color, etc. So that's the pattern. You see that every line is on the grid. Nothing is. We have no extra line.
Sometimes you have to add something, but these are minor things.
No, but here on this one, it's perfectly on the grid. Nobody outside the grid. So this is so you have to analyze the symmetry. First, that first axis of symmetry. You see, this pattern is repetitive because it's periodic, because the stars are traveling along this axis, but they are traveling also along the other axis. So, you see, I can reduce this pattern to this element. This element that in France we call it's the translation unit, because I can make the pattern with this using only translations. No rotation, no symmetry, just translation. So, but now, like what I showed you before, I can reduce this translation unit because here we have more symmetry. We have one more symmetry axis, okay? So I can reduce it. And inside the new, inside we have rotation, symmetry of rotation of order 3. From this center, you can rotate 120 degrees. So I can reduce again into this pattern, and this, you see, I cannot reduce it because there is no more symmetry. So that's what I call the seed of the pattern. And from that seed, and you see it is much more complex than the one we had before, more complex, more lines. From that seed, you can do the way back to the whole pattern. And this is what we call it's question of symmetry. So this pattern is the seed, and a way to make the pattern from the seed using a set of symmetries. And this is a structure with here we have axis of rotation of 2, of 3, and of 6 here. And this structure in mathematics is known as a symmetry group. And you know, you have that we have only 17 kind of structure like that to make periodic pattern on a plane. And this one have a name. His name is P6. No, okay, but I come back to the kind of method like the one you presented yesterday. It's what we call step-by-step method. So you have a pattern, and how can I do the pattern? So I don't think about where is the key of the pattern. No, I just follow a recipe. I have to do this and that and that. An example, funny example, very funny is that one. It's from a book. Maybe you know that book. And it was the second book of the author with the same pattern. So it pretends to analyze this, not to analyze, but to give a recipe to do this pattern. So how does it work? This pattern is considered to be simple level. Okay, so how does it works? But first, through square, make the octagonal star. It's okay. Then those dots, draw that lines. Okay, and cut the pattern here. And then you plumb, and then this. You got this. It's very yes. It's quite simple, isn't it? And that's the result. But that kind of construction, it's good if before you have correctly understood what is this pattern, if you know the key of the pattern. But even in that case, the problem is that what you get is not the pattern. Look at the star here, the poor star here, and the poor petal of the octagon, and compare to this is exactly the pattern that is in the book, but look at the stars. The stars here are very nice. It's easy. Everybody can see the difference. So another example is this one in Morocco. It's the same. Look, the stars and the petals are correct. It means that in fact the petals have to be and the stars have to be as regular as possible. And for that there is just one solution. Just if you the hypothesis The good hypothesis is that I want to have petal and star as regular as possible. So you get just one solution, but it's not the one that is which is in the book. Yeah, another one. This is a design. The pattern probably was from Egypt. This is from Bourgoin. So Bourgoin is better, but the stars are not that much regular, but it's better. Next, here again, it's Bourgoin. From the Bourgoin book, I guess you know this book. Everybody has to know that book. No, Eric Broad was the first, but this comes from a very interesting book from IT 70, something like that. Yes, thank you. And from Jean Bourgoin. If you want to buy the original copy, it can be between 1,000 or 2,000 euros. I have 3 copies, but I didn't pay that price. I just steal it. So, and look, this one is another plate on Bourgoin book, and you know that here, in that case, the star looks much more better, and the petal here looks much more regular. So I think here he did the right hypothesis, but not on the previous one. And another one, and this one is the best drawing. This one here, it's from Anthony Lee, and this one is perfect because he perfectly analyzed the pattern. Okay, Anthony Lee is he's really a great man, very skilly. He did a huge and very important work. You can find some of his booklet in online. It's amazing. Anthony Lee. You have another Lee, which is Peter Lee. Yeah, take care. It's not Peter Lee. It's Tony Lee. Another one, because it's amazing, from the same book of the first pattern. No, Bourgoin. In fact, yes, it's Eric Brou. The same book. This pattern is he considers this pattern to be a complex level, and he gives a recipe. There is no key, no analyze. You just have to follow. And doing this, okay, you learn how to use the compass and the ruler, but you are not doing geometry. So first step is okay. Then this, then that. It becomes complex. Here it becomes much more complex. Very, very complex, yes. And finally, it's finally you get the pattern. Okay, that kind of pattern can be drawn on a grid. Take care. What you draw on a grid is just an approximation. But from this approximation, you can very easily go to the perfect pattern, because we use tiles and we know perfectly the real dimension of the tile. So, first can you see the square here, maybe a little bit? What I use a grid, and oh, okay, I can use like that, like that, like that, like that. It's not good. I'm drawing octagon on the grid. I don't know if you can see exactly, but you understand. I think this point is on the grid, that one on the grid, etc. So here, it's not a good one. It's bad because the edges are not equal. But never mind. I said this has to be equal, and then I can continue. Then I need to have that. Okay. The pattern is like that. And we have mainly what we have to draw is that. So octagon, you can draw octagon, and that shape. What you have to know is that this shape is exactly made of two squares. This is a square, this is a square. So if you can draw an octagon, this is supposed to be a perfect one. Very bad drawing. Okay, you can do it perfectly. And okay, so you know the good dimension of that. And what you have to do is to draw a square here. You can draw a square, another square, and you have the second shapes. Everything comes from these two shapes. But you will experiment that on the workshop if you would like to come to the workshop. So you know the point is that it's very easy to draw this pattern using a grid. So here I have my square here. Try. Okay. Never mind. It's not perfect. So I have to do the same here. Square. I cannot see the grid, but never mind. And here, that is the center. At the center, you have another star. And what happened here now? This line want to go like that. This line want to go like this. This one like that. This one like that. So here I have a star with petals like that. These petals are made of two squares, and the idea is to have the same here. So I just draw the square here, and I got this. And the line here, I just join together. And that's right. Here, what I have to do is just to add this. And this is the same shape on that. So that's the pattern. But you will experiment that at the workshop. What I want to say is that it's much more. When you understand the key of the pattern, things become much more simple. And if it is simpler, it is better, in my opinion. So I should start this. Some comments about polygonal system. You remember the polygonal system I show you? Something else. I have a comment because everybody can make errors, and so, for example, I show you this star here. In fact, the hypothesis I did is to have here the standard tenfolded star where the petals are as much regular as possible. And in fact, in that situation, it's not the good one. In this situation, yes, it is. Because in this situation, it's better to have another solution with petals longer, not regular but longer, in order to fit better with the other tiles. That's all. But it's not any dimension of the branch. The dimension is set up with another wall. Never mind, another time. Anyway, you see. For example, here, if you look here, no, here it's the same. In that case, this pattern with the polygonal system, I draw the polygonal system from my polygonal lines that I design on each positive tile. I told this about that on Saturday. So I got this, I remove the orphan lines, and I got that. So some polygonal lines are missing. I have to define new polygons to fit here and there. So it comes like that. But the problem is that here, on this area, I cannot define polygons. It cannot work. And I need more polygon like that. And the problem is that those polygons are not as elegant as the first one, because they are not equilateral. It means that some edges are the edges are not the same length, and sometimes the angles are not the same. Here the angle is sharp, here the angle is different, and sometimes I need to have not one vertex on the edges, but two vertex on the edges. So here things become more complex with a polygonal system, and so I need more and more different polygons. Here on this line are the elegant polygon, because it's always the same rows, but we need more and more polygon like that. I want to show you just one example from J. Bonner. J. Bonner. So this pattern comes from the Alhambra Palace. Yeah. Of course, it's from J, so it's a good analysis, good reconstruction. The pattern is exactly like that. And here is the analysis and the reconstruction in terms of polygon lines. But these have been made from the pattern. So first there is the pattern, and then you draw that polygon. So of course it works. It works, but it's not. I think it's not very elegant, because you need to define this area, so which is a special polygon, and we don't know how it is constructed. J no, of course. And you have, for example, you have octagon, but you don't have one octagon. We have this one with a star inside. We have that one with just one line inside, and maybe some yeah. So what I want to say is that this system, I don't recommend this system for the Moroccan style. For the Moroccan style, it works better like that. Alors, I want to. Merde. Because this pattern comes from the Alhambra Palace, from a room which name is Comares room, and all along the room you have all these patterns. So when you put patterns, when you see patterns together, you understand that it's the same family. All are variation from the same. You know, the tiles, the shape of the tiles are the same. The length of the square is the same. It's just variation. So this one is the first. It's the simplest one, and it comes from the orange line. This is a skeleton of the pattern. The first thing is to think about the skeleton, and the skeleton is made with that. And so the same. So, and if I want to design it, I can design on a grid again. First, this is my the structure with only this and that. So here it's an approximation, but I know perfectly the real size, so I can go from the approximation to the real thing. And then I have to continue, because here you see from here the line have to continue, and here there is just one solution. I have to continue like that, etc., etc. And the pattern J was talking about is which one? Is that one, and that one. It's just a variation of the first, which is simple, and you can recognize here again the skeleton there. Skeleton is here on top. It's a star here, connected here with the frame, and it's okay. So just I end with just a small animation, if I can find it. Because another point of view, in fact, my point of view of patterns is something like metamorphosis or genesis of morpho. It's kind of morphogenesis. I like to start from a very simple thing, and with simple rules go to things more and more complex. So I want for you just an animation that for that point of view. It's a I'm sorry, it's a very old animation. I did it years and years before, but it still works. Sorry for someone here who already have seen it. Yes. So a star from Greece. The mother of that family of pattern is the octagon, and just sample transformation of some type. Well, this is a little bit tricky, but I wanted to go to that star from the Alhambra, and this is new thing. It looks new because it's pattern inside the pattern inside the pattern. It can continue infinitely, but I'm sure I know that the artists of the Alhambra, they have this in mind because they have written in a wall all you need to do that. Yes. Okay. I think that's okay. That's all for and I goes back to the simplest thing. With music, nice music of a friend of mine.
Yes.